What's up, everybody? All right, so we're moving away a little bit from the whole similar triangle thing, and we're going to look at how parallel lines can kind of cut triangles up proportionally. So we're still going to be dealing with ratios, but we're no longer going to be doing similarity statements. It's more about, okay, we have parallel lines within our triangle. How does that affect some of the measurements or segments that creates? Okay, so here's what I mean by the parallel lines, right? So you have one triangle that now has another parallel line drawn through it, and yes, it is creating a similar triangle, so this tiny little triangle in here is similar to this big triangle. But there's other things that we can do now to make some ratios that might make it a little bit easier. Okay, so first things is we know that they're similar because remember we have that reflexive angle at the top, so angle A is the same in both triangles, and then you have your corresponding angles here because of the parallel lines, this being the transversal. So those two triangles are similar via angle. Okay, so if a line is parallel to one side of a triangle and intersects the other two sides, so notice how EB, side EB, is intersecting AD and BC, AD and AC, and it's also parallel to the third side. So it's parallel to one side of the triangle and intersecting the other two sides. Then it divides the sides into segments of proportional lengths. Okay, so what we're going to be looking at is like this segment here and here, and these two segments here. So what this is saying is that AB over BC, so notice I'm sticking to this side, so AB over BC is equal to AE over ED. So it's just a way that you can do a proportion without having to compare both similar triangles. And again, this only works for if you have parallel lines within a triangle, okay? And so the converse of that is also true, meaning if you know that B and E are midpoints, you can conclude that it's parallel, all right? That's kind of just one of the things to go along with it. So as I look at this diagram, it's pretty much the same diagram right now. I've just kind of I've just changed where the parallel line is drawn. Okay. So if I wanted to solve this scenario for x, there's actually two ways you could do it. Okay. So I'm going to show you the way that we could do it using the new information, but I'm also going to show you the way that we could do it using the old information. So remember, we still have two similar triangles. We have these parallel lines. Now, you want to make your ratios sticking to the same side length. So I mean, like, I'm going to stick with this side length right here. So 7.5 over 3 is equal to, now notice for me, the way I read this is left of the parallel line, right of the parallel line. So left over right. So I'm going to stick with that same theme, left over right. So that's going to be x over 2.5. And then once we get to there, we can just cross multiply, right? So I'm going to do 7.5 times 2.5. That gets me 18.75 equals 3x. Divide that by 3. I get x equals 6.25. So that's the new way that this can be done. Now, the old way that this could be done is if I'm going to compare lengths of my small triangle to my big triangle. So the 7.5 of the small triangle corresponds to this big length of my big triangle. So that would be 10.5, 7.5 plus 3, equals x, my small length, over my entire length, x plus 2.5. Cross multiply, 10.5x equals 7.5x plus 7.5 times 2.5. Gets me 18.75. Subtract the 7.5, so 10.5 minus 7.5 gets me 3. So 3x equals 18.75. Notice we're getting to the same point that we had over here. But look how much less work this was compared to the amount of work that this was, right? And so that's why we show this shortcut, so that anytime you have parallel lines in a triangle, it's cutting up these little segments proportionally. So you don't have to focus little triangle, big triangle. You can just focus on this piece over this piece and this piece over this piece right here. Okay. And so guys, that's going to carry over into something at the end of this lesson as well. So mid-segment of a triangle. Now we've talked about mid-segment before for other different shapes, specifically most recently a trapezoid, right? And so remember, a mid-segment connects the midpoints of two sides. So the mid-segment of a triangle is always parallel to the side it's not touching. And it connects the midpoints of the sides it is touching. So if I go back really quickly over here, okay, it would look like this. However, this length and this length would be the same, and this length and this length would be the same. Okay? So the mid-segment of a triangle is parallel to the side it's not touching, and it's connected to the midpoints of the sides it is touching. So right here, that means that ZW will be parallel to YX, and then this side is being cut in half by ZW, and this side is being cut in half by ZW. Just like that. Okay? So that means that ZW is a mid-segment of this triangle. Okay? And so the mid-segment is half the length of the side it is parallel to, or half the length of the side it's not touching. So ZW is half of YX. Okay? So let's look at an example problem. Okay, so there's a lot going on here. Now, the Y is representing what is that Y representing? Oh, it's just representing a point. Okay, so Y is this point here, X is this point here, and Z is this point here. Now notice that X, Y, and Z are all midpoints of the sides of the triangle. We know that based off the markings. Single dashes, double dashes, and then obviously you have your triple dashes. So again, X, Y, and Z are all midpoints. So that makes this a mid-segment, also makes this a mid-segment right here. Now what we're able to conclude then is that these orange segments are parallel, okay? And then these yellow segments are parallel as well, okay? So knowing that, what is our length of XZ? Well, remember, the mid-segment is half the length of the side it's not touching. XZ is not touching RT. So if RT is 13, that means XZ is 6.5. Okay. What is the length of ST? Well, ST is not touching XY. XY is 7. XY is half of ST, so if XT is 7, then ST has to be 14. And then finally, the measure of angle RYX. So angle RYX is this angle right here, okay? So how can we find the measure of RYX? Now there's two different ways you could think of this. And you want to focus on the parallel line. So RYX, which is right here, we have a parallel line and a parallel line. Remember, this is now a transversal, so RYX is actually an alternate interior angle with this angle here. So RYX is congruent to that 124. The other way you could think of this is we have consecutive interior angles here, so you could do 180 minus 124 to find that angle in black, and then we know that these two angles are supplementary, so 180 minus 1, whatever this is, okay? But I would recommend just seeing that it's alternate interior angles, okay? Let's do another example like that, okay? So again, looking at this diagram, I know that D is a midpoint, E is a midpoint, and F is a midpoint, which makes our two little orange segments here mid segments, right? I also know that FE is parallel to AB, and I know that DE is parallel to AC. So DE, so trying to find the length of DE. Well, AC is 15, which means that DE has to be half that amount, 7.5. DB is right here. Well, I know that this length is double this length. But if this is 9.2, then this would also be 9.2 because the whole thing is double 9.2. And I know both of these are the same length, so it'd be AB divided by 2, which is 9.2. So this is 9.2. And finally, angle FED, which is this angle right here. And again, remember, parallel line, transversal, that angle is also 82 degrees. Okay, alternate interior angles. All right. Last thing, proportional and congruent parts of parallel lines. So this is going to kind of carry over from the triangles. Okay, so but now I'm going to have 3 parallel lines instead of 2. Okay, so if you were to imagine that these would eventually kind of come together all the way down here, you'd still have a triangle, right? So the concept still carries over. So if I had 3 parallel lines, then all these little segments are getting broken up proportionally. Okay, so AB over BC is congruent to FE over ED. And again, guys, that just directly carries over from what we had like this, where if I had A, B, C, D, E, AB over BC equals AE over ED, right? Same concept, exact same thing. And then also, if you know in that same type of diagram that B is a midpoint, then you can conclude that E is also a midpoint, just like that. So that FE has to be congruent to ED. Okay. You're going to have a couple problems like this on your homework. I'll make sure to talk about them when we get there. I don't want to spend too much more time in the video. So last thing right here, so notice that these are both congruent. Now, if both of those are congruent, these have to be congruent as well. So I can just do 7x minus 2 equals 4x plus 3. And the key to being able to understand that is noticing that these lines are all parallel. Okay. So I'd subtract the 4x, I'd add the 2, I get 3x equals 5, so x equals 5/3. Okay. Not very many homework problems tonight. Let me know if you need any help, as usual. All right.